All right, let's introduce ourselves to drafting. And basically, drafting is a interesting way of saying drawing in a technical way. Some cases you might be drawing a model. Sometimes you might be drawing a layout. You might be drawing a full blueprint, a building. It could be anything. That is drafting when we do it in a technical way that's able to be understood by other people. So we're going to look at this dimensioning vocabulary and rules sheet. And if I zoom in a little bit here, you'll see that we have terms here, extension line. Move this down a little bit. There we go. We have extension lines. Oh, that was too much. Extension lines. And then we have dimension lines. Okay. So let's start with extension lines. Extension lines are these lines here. Okay, here and here. And they do what they say they do. They extend out the top portion of this drawing out here, and they extend out here. And all it's used for is measurement, okay? So what we're accomplishing here is we're showing the measurement from the top to the bottom. And putting an extension line here and here, as well as dimension lines, which are these arrows, we are telling us that we are measuring, or the dimension refers to this line here to this line here, that distance, okay, which is the same as top to bottom. So in this case, it's 1 inch. All right, if you look at the bottom, which is the same as the top, so from side to side, okay, extension lines and dimension lines, we have 3/4 of an inch, okay? So that is a technical way of dimensioning or writing in the dimensions of an object that you've drawn, okay? So what does this have to do with our class? Well, in our class, we do a little bit with just basic shape technical drawing. We could spend more time and go into this three-dimensionally, but since we have good software to help us with that, we will leave that up to the software. But for this video, we want to make these two shapes, and we want to draw this little bedroom here, okay? One thing I want you to notice about these shapes is that they are 6 feet wide by 2 feet tall. Well, the question is, how do you do something like that? How do you take a sheet of paper and draw something that is 6 feet wide by 2 feet tall? Obviously, you'd need a 6-foot piece of paper, and that's not realistic. So what we have to do is we have to use something called scale. And we are going to scale down or shrink down the version that we're trying to draw, okay? So in this case, we're going to make a drawing that has a scale of 1 inch equals 1 foot. So for every foot in real life, on paper, we will draw 1 inch, okay? That way we shrink it down in an equal ratio everywhere around the drawing, all right? So let's do that. We're going to do these two drawings. And for this, you're going to need a sheet of paper. So go ahead and get that, and a ruler with inches on it. And you will need a pencil. It's good to have an eraser nearby just in case. I'll put my eraser there. All right. So the very first thing we should do is write the scale. It's important to have that so that whoever is looking at this drawing can see that you're doing something to scale. So I'm going to write that right at the top. Scale 1 inch equals 1 foot. Okay. So for every inch in real life, we're going to draw it. I'm sorry, for every foot in real life, we're going to draw it as an inch on this paper. So that first drawing, ruler was upside down. That first drawing, we did a 6-foot line. So 6 feet is the real life version. If we know it's 1 inch for every foot, then we know for 6 feet, it's 6 inches. All right, so let's draw a 6-inch line. If you have graph paper that is 1 inch graph paper, in other words, the squares are 1 inch each, you could just count 6 boxes, and that would give you 6 feet, okay? So Now we've got the top one. Let's do the side one. We know we were looking for a 2-foot side. So go ahead and follow along with me. Pause if you need to. 2 feet. I'm going to do 6 again on the bottom. Try to make your lines as perpendicular as you can. And then 2 feet on the side. Now, you'll notice that you didn't end up with 2 feet if for some reason your dimensions are a little bit off, or if your angles aren't quite right angles. But now that we've got this drawn, we need to dimension it, because right now it just looks like a rectangle. So we know this side is going to be 2 feet, and we know the bottom is going to be 6 feet. Okay, we don't have to put a dimension up here or over here, because these are the same and the top and the bottom are the same. Okay, so let's draw in our extension lines. You can do this with a ruler, or if you're really good at freehand, you could probably just draw them that way too. So I'm going to draw them with a ruler just to be neat on this first one. And then draw an extension line here. And an extension line here. It doesn't have to be a certain length. It just needs to be kind of like a short distance. Now we need to draw in our dimension lines. And remember to put an arrow on the end. We'll do the other side, an arrow. And over here, same thing. Draw our 2 lines. And remember to put your arrow. And so what that essentially tells us, if I zoom in a little bit here, what that essentially tells us is that the distance from the top to bottom, which extends out this way, is 2 feet. Now, on the paper, I drew 2 inches, but remember, we are representing on paper something that is much larger in real life. Okay, we've scaled it down from 1 foot equals 2 inches, or 1 foot equals 1 inch on paper. So 2 feet here, 6 feet here, and we're done. All right. So let's take it a step further. And again, pause as you need to in order to keep up with the drawing here. Let's do a drawing that's not exactly a rectangle. All right. So I'm going to make that one 6 feet. I'm going to go ahead and dimension it right away. And let's take the side. Again, try to be as perpendicular to your other lines as possible. Let's do the side at 4 feet. The bottom, let's go 3 feet. And then this side, line it up nice and perpendicular. We're going to go 2 feet. Okay, so that's 6 feet here, 4 feet here, 3 feet here, and 2 feet here. Okay, and then I'm just going to make kind of like a corner. So this is going to be almost like a corner shaped room. Okay, so I'm going to go back in 3 feet. And then I'm going to go down what should be 2 feet. And for me, it is. If you did nice right angles and perpendicular and parallel lines, you should have come up with those dimensions. Now, you might be wondering, do I need to put a dimension here and here? Well, the answer is no, because all the information we need is already on here. We don't want to clutter it up with extra dimensions when they're not needed. So we know if the top is 6 feet and the bottom is 3 feet, what's left over here must be 6 minus 3, which is 3 feet also. Likewise, we know if this is 4 feet on this side and 2 feet here, then this over here must also be 2 feet, because 4 minus 2 equals 2. And because we can do the math on it, we're not going to add the dimensions, because it's just going to make things too busy on here. All right. You only want to put dimensions where they're needed. So now I'm going to just kind of freehand draw extension lines. If you can't draw them real neatly, and again, they should be exactly parallel with this line. Okay. If you can't draw them in neatly like this, then by all means use your ruler to make them nice and straight. Okay. And I'm going to draw in my dimension lines. Okay, little arrow. And you'll need dimension lines all the way around. Draw your arrows. Don't forget your arrows. Your arrows should point exactly to the point right there where the extension line comes across. All right. And one more. And there we go. All right. So you've got two drawings right here. We've used the correct scale. Sometimes they call this 1 inch scale, meaning 1 inch equals 1 foot in real life. Okay, so 2 foot here should equal 2 inches on the paper. Yep. And that's how you do scale at 1 inch equals 1 foot. Let's flip this over though. What if we wanted to put something bigger? Okay. In other words, something that won't fit on the paper, even with that smaller scale. So let's take our example here where we want to draw a bedroom. Okay. If it's 11 feet wide by 17 feet long, that would mean at 1 inch scale, we'd need an 11 inch piece of paper this way by 17 inches this way. And we know this is a standard piece of paper. That is not what we have here. What we have here is 8.5 by 11. That scale is not going to work. So what scale is going to work? That's the question. Well, if 1 inch equals 1 foot doesn't quite fit onto the paper, what we could do is shrink that even more. We could shrink that in half. In other words, instead of 1 inch, we'll do 1/2 inch equals 1 foot. Okay, that should fit on there because we know if we had, say, 20 feet, we would only need 10 inches of paper. Okay, 20 times 1/2, 1/2 inch times 20 is going to be 10 inches, and that would fit. Okay, so let's draw this. Now, here's the big question. If you want 11 feet on the top, we know we want 11 feet. How many inches is that going to be at 1/2 inch equals 1 foot scale? Well, there's 11 feet, and each foot is 1/2 an inch, so that's 11 1/2 inches. Okay, you could either add them all together and get 5 and 1/2 left over, or you could multiply 11 times 1/2, which gives you 5.5, or you could divide 11 by 2, which gives you also 5.5. So we're doing a little math here, okay? So 5.5 inches. And because we're doing 1/2 inch scale, we're able to say that that distance here in real life is 11 feet. And notice, feet is an apostrophe. Inches is a quotation mark. Big difference, okay? Make sure you got that correct. All right, down the side, we're going to draw 17 feet. 17 feet at this scale means we're going to take 17/2 inches. And if you divide 17 by 2, you get 8.5 inches. Okay? But again, we're not going to label this 8.5 inches. We're going to label this 17 feet. There is a difference. If you were to put in a blueprint and send it off to a manufacturer and say, hey, I need this, and you wrote, instead of 11 feet by 17 feet, and if you accidentally wrote 5.5 inches times 8.5 inches, even though you may have meant one thing, they're going to build something that's really, really small. So they're going to use what's on the paper, all right? You're just scaling it down, okay? So across the bottom, we're going to go the same distance as the top. So let's go 5.5 inches. And I'm not going to draw all the way up yet. I'm going to make it a little interesting. This is a bedroom. We need to be able to get in a bedroom, okay? So I'm going to draw 3 feet down from the corner, okay? 3 feet is 3/2 inches. Add 3/2 inches together and you get 1.5 inches. And then I want to leave 1.5 inches, okay, open. That's going to be for a door, all right? So 1.5 inches means another 3 feet in real life. And then I'm going to draw the rest of the way down. Okay? Then let's start putting in some of our dimensions. All right, so these are our extension lines. And while I'm doing this, by the way, I'm not going to draw here, and I'm not going to draw here because I don't need to. All those dimensions will be mathematically figured out, so we don't need to write them in. But while I'm drawing these in, by the way, this is 3 feet, try to figure out if you can tell how long this distance from the end of the door to here is. If you know this is 3 feet, this part of the wall, and it's a 3-foot wide door, and it's 17 the whole way over here, what's this remaining wall going to be? So while I draw in my dimension lines, you can kind of do that math in your head or on a calculator, whatever you want to do, and we'll come back to it. Okay. Oops, got in the camera there, sorry. All right, and one more to do over here. And then we will come back to my little math question there. All right, so now I've got everything dimensioned. No, it's really hard to get that to fit on there, so we'll just ignore the bottom part and just kind of focus on the top part. So if we have 17 full feet over here, 3 for this wall and 3 for the door, what does that leave us? So 17 minus 3 is going to equal 11 feet over here. I don't need to write that in because by labeling the door as 3 feet, which we will in a minute, and knowing that this is a 3-foot wall here, it makes sense to the whoever is building this that what's going to be left is 11 feet. Okay? So that's how we do it. 17 minus 3 minus 3. 17 minus 3 is 14. Minus 3 is 11. That goes all the way down. Okay? So one thing you might have noticed if you're really thinking is that this doesn't look right for a bedroom. How can a bedroom have a wall that's just the thickness of a line? Well, it can't. A wall has a thickness. You know, usually in a wall, you'll have the stud board, and then you'll have 1/2-inch drywall on each side. And usually that ends up being about 4 inches to 4.5 inches, okay, in real life. We're going to keep things simple for this drawing. And we are going to say it's a 6-inch wall in real life. So 1/2 of a foot in real life. Well, if 1 foot equals 1 inch on this scale, what does 1/2 of a foot equal on this scale? Well, 1/2 of this number is 1/2 of a foot, or 6 inches. 1/2 of this number, 1/2 of 1/2 is 1/4. That's where you need to know some of your math. You need to know some fractions, okay? So if I want a thickness of the wall to be 6 inches, I need on paper to go in 1/4 of 1 inch to stay at this scale. So I'm going to go in 1/4 of an inch. I'm going to measure it on this first one. Let me redo that. I'm going to measure in 1/4 of an inch. And then I'm going to just kind of, for the sake of time, I'm going to estimate that distance all the way around, although I think I'll estimate pretty accurately here. So 1/4 of an inch all the way around is going to give us our interior wall thickness. Okay. And almost done. And then let's finish off the wall. So now I've got a nice exterior wall, which is the outside. We've got a nice interior wall, which is the inside. If we really wanted to, we could do the dimensions here. If this is 3 foot from outside to outside, and this is 6 inches thick, that means we've got 2 feet 6 inches left in here on the interior. But we don't really need to put that in there because all the math is already here. If we really want to do something, let me zoom in here. I could draw a little tiny dimension line in here like this. Put a little tiny arrow and a little tiny arrow. All right. And I could just do a little call out with an arrow and put 6 inches. Now, there's no way anyone's going to have any confusion. So now they know the size of the walls on the outside. They know the thickness of them. All the information's there. The only thing really left for the room is a door. And I want it to swing into the room. Well, if it's a 3-foot door, 3 feet at half of an inch each is 3/2 inches or 1.5 inches total. Okay. Then I'm just going to put a little curve here. And that curve represents the sweep of the door. Okay. So what this thing tells us is that in this bedroom, we have the door hinge on the inside of the room. Okay. And the door hinge is going to be on this side. And as you walk in, the door is going to swing into the room. Okay. If we wanted it to swing outward, we could draw it like this over here. I'm not going to do that, but you would put it on this side of the wall and have it this way. That way you pull the door open as you go in. But most bedrooms, you push the door into the room. Okay. And this tells us which side the hinge is on. All right. I'm even going to label this 3068. And that gives the exact size of door that we have here. All right. And that tells manufacturers that it's a 3-foot 0-inch door wide by 6-foot 8-inch door tall. Okay. Or 3 feet by 6 foot 8 inches. 36 inches by 80 inches. Because 6 feet is 72 inches plus 8 inches more makes 80. Okay. So this tells us it's a 3-foot wide opening. Okay. Roughly. So an architect and a builder will be on the same page if they see this. They'll know exactly what to do. All right. So let's go ahead and let's draw a dresser in. I'm going to say the dresser, let me think about this. Let's say the dresser is 1.5 feet, like deep. Okay. 1.5 feet in real life is going to be a 1/2 inch plus 1/2 of a 1/2 inch more. So 3/4 of an inch. Okay. So we'll make a 3/4 of an inch and let's keep it simple and say it's a 2-foot wide dresser. There's a little glare there. We'll say it's a 2-foot wide dresser. So 2 feet 1/2 an inch each is 2/2 inches. Oh, I did something wrong there. 18 inches. Let's say 2 feet. Let's just keep it all simple. Let's just say it's 2 foot deep. Okay, so that's going to be 1 inch. Instead of making these partial inches. Okay. And let's say we'll say it's 3 feet wide. Okay, so 3/2 inches makes 1.5 inches. Okay. And then obviously 1 inch back means 1 feet. So this is a dresser. You don't normally on a blueprint, you wouldn't write in furniture, but you could just for safe, just to let people know what you're doing. Let's say we did a bed down at the bottom. Let's say the bed is 6 feet long by, we'll just say 6 by 6. So, well, no, let's do 6 feet by 4 feet. So 6 feet long is going to be 6/2 inches, which is 3 inches on paper. So 6 feet there. And we'll say 4 feet wide. So that's going to be 2 inches on paper. Okay. Again, you don't normally draw furniture in on a blueprint, but we're doing it just for good practice. Okay. So there's our bed. If you really wanted to, you could even draw in some nice square pillows just so it kind of looks like a bed. Very squared off bed. Okay. You could draw other furniture in here, but we're not really interested in doing that. And the only thing left to do is give this room a name. When I give a room a name, I like to put a line down to write the name on, just to make it stand out a little bit. And bedroom. And that is it. So on the first side, and I'll flip this over again, so just relax. On the first side, we've got 1-inch scale. Okay, we drew these shapes, general shapes for practice. On this side, we've got 1/2-inch scale because we couldn't fit 17 feet on one sheet of paper. All right, and we've got 11 by 17. We've got a 3-foot wall. We've got a 3-foot door, 6-inch wide wall outside the interior. The door swings into the room. We've got a dresser and a bed, and we've got it labeled. And that is how you do it. This is a very basic way of doing it. As we move on, you'll find that programs like SketchUp and other architectural programs allow you to do this very simply and very quickly using the computer and perfectly accurately, which makes you appreciate them a little bit more. But every once in a while, it's fun to draw something on paper. So hopefully you remember that when we do our, I'm not going to exit. I'm just going to go back to my Canvas page here. You can see that these things were just simply done on paper using different scales. So we did 1-inch scale up here, we did 1/2-inch scale down here, and we came up with a nice drawing. So give this some practice. Watch the video again if you need to. Pause it as you need to. Follow along, and hopefully you can come up with a nice drawing just like that all on your own.